In this video, let's introduce ourselves with continuous distribution function. Let's also discuss probability density function, which is just another way of expressing a continuous distribution function. Continuous distribution pertains to a particular case, event, or a point, but probability density function pertains to a set of cases, events, or points on the continuous distribution graph. We will study them ahead. Let us discuss the same taking dice as an example. Later you will be introduced to multiple real-time scenarios. We know that there are infinite integers on an open-ended number line from -infinity to +infinity. But a dice in its single throw allows only integers values between 1 through 6, both inclusive. So, value of x, the possibility variable, can range from -infinity to infinity, but the probability of x being anything other than 1 through 6 is 0. Now in the 6-faced dice, probability of throwing a negative number or a 0 is 0. Also, the probability of dice throwing a number more than 6 is 0. The probability of dice throwing between 1 and 6 inclusive is each one divided by 6, which approximates to 0.17. Hence, we have the distribution function shown here. We can express the distribution in three formats, either an equation, a table, or a graph as shown. And, when we know the allowed range, like here in case of dice, we know that the allowed range is from 1 to 6. So, we can trim the graph like below. This also means that the probability of x being any number between 1 through 6 is 1 and not being any of these is 0. This means that the probability of sum of all the possibilities is 1. Now, let us learn to look the possibility variable as a range. Let a and b the limits of the range. Then the probability distribution function can be expressed as f of x equals the probability function of the events between the range a and b, both inclusive, expressed as the integration or the summation of all the events from a to b. Now, let us evaluate the probability of the dice throwing a 1. In this case the range is 1 through 1, meaning a equals 1 and b equals 1. Hence, according to the probability distribution, f of x for the range 1 to 1 both inclusive is nothing but 1 divided by 6 from the table. Now, let us evaluate the probability of the dice throwing any number between 2 and 5. Clearly, here a is 2 and b is 5. Hence, to evaluate such event to happen, we sum or integrated the probability of all the events in this range. Hence, the probability of the range is equal to the sum of individual probabilities, which is here the probability of event 2 or probability of throwing 2, plus the probability of event 3 or probability of throwing 3, plus the probability of event 4 or probability of throwing 4 plus the probability of event 5 or probability of throwing 5. The result is 1 divided by 6 for throwing 2, plus 1 divided by 6 for throwing 3, plus 1 divided by 6 for throwing 4, plus 1 divided by 6 for throwing 5.